Hi, welcome everyone. In today's video, I'm going to show you another algorithm that can help you to do new types of tests that can go with new regression estimations. So in this video today, what I will I will show you how to do a unit 2 test for a time series data, but do a unit 2 test quantile wise. So what is the need for this method? Let's suppose you are doing a quantile ARDL regression for time series data, or even a quantile regression in a cross section data, or specifically time series data, because the unit 2 test is used for time series data. So what you can do is that in this algorithm you will be able to split the data into different quantiles and then do the standard unit 2 test. In this video I will be doing the augmented decay Fuller test, and I will also show you how to modify this command for other tests. So be with me. What we can do is that you will increase the amount of computations for your complicated regression model. So we'll start with the codes. I will increase the font so that you can understand and read, and while the codes will also be available in the comments. So you can read the data using this command. So this data is some stock market data for Pakistan and Malaysia for like 2,300 observations. So it's a long enough data so that I can separate it into different quantiles, and still there are enough observations left so that I can estimate the model. So I will start with the codes. So you have to declare that data is time series. Control D. It will declare the data. Now this command will convert create a scalar that is counting the quantile value. So I'm also deleting the useless commands here. So when you do this, it will locate the quantile number for each observation and label it in terms of quantile from 1 percentile 1 to percentile 100. So you will be able to locate the data. So it is made in terms of Malaysia data. So this is just data, and then what I'll do is that you have to open the temporary folder and say that my temporary folder name is holding, and it will clear any folder that has been made earlier. In that folder, it will create three columns: quantile, test, prob, and named as holding. And then I will start a loop from 1 to 19, and this loop will be the loop number will be multiplied with 5, so that 1 will become 5 and 2 becomes 10, so on to 95. So it means these are my quantile numbers from 5 to 95 with a jump of 5. Then I will say that do a decay Fuller test on that variable if that data group value is less than the percentile value or quantile value coming up from the previous command, and with 0 lags. Now you can add any lag that you want. You can change it here, and you can use any other Philip parent or any other parent time series unit of test and change the command here. And if you want to add trend, you want to remove the intercept, you can modify it here. So this command is flexible. But when you change the model from decay Fuller to some other, then you have to change these values. So I will tell you how I got it. So for that you have to write here the Fuller. So in that loop, if you go down, it will tell you, so these are the scalar outputs. So I know that this is the value that I need. This is the test statistics, and this is probability. So if you use any other, like if you use p parent, so you have to go down and have a look what is the name. So p parent is also zt, and its probability value is zp val. So you have to change it when you are using Philip parent or any other. You have to go down its help menu and see how you can use it. So I will come back. Now it will store the zt and p. Now it will display. So I intentionally create this so that I can see if the data is being stored correctly. Then this command will store that output in temporary folders. Then loop will close, and it will close this temporary folder that was storing the data, and then use that and load that data. So it was in the temporary holding name folder, temporary data name in holding. Now I will use and remove the previous data. So when I run it, let's start from here. It will run the loop 19 times and it will do 19 unit 2 tests. For after each test, you will see the percentile value and the test statistics and its p-value. So there are 19 observations, and then data is stored and it is shown here. So if I open the data, you can see the percentile value, test value, and probability. Now one extra thing that you can do is that you can make a graph out of it so that you can display it on your thesis or a research paper. So for that, the two-way graph, line test quantile, line probability quantile on y-2, title will y title will be test value, x title will be quantile position of variable. You can change the variable name. Title will be quantile wise ADF unit to test. So when I run it, so this is another unique way to present your unit to test when your data is long enough. If data is not very long, you can reduce the number of percentile positions. Rather than 19, you can make it 3, like at 25 percentile, at 50 percentile, at 75 percentile. How you can do it? You have to change the loop and then accordingly, and then so you can see the test value is increasing and the p values are also increasing, but still less than 0.05. So it is showing that the data is the alternative hypothesis is accepting for the ADF unit to test for all percentile positions. So there is no ambiguity in the data that it is switching from null to alternate at different percentile positions. So this data is not, let's say, not mixed order of integration within different positions. So it can be used as a non-stationary variable throughout the data if you're using the Quantile ARDL model. So let me know how you like this model. When you complete this model, you have to load the data again. So your command is here because the temporary folder has replaced the original data, so that you can do it for your other variable. So I hope you like this innovation that can be used in your time series estimation, especially in financial economics or even in finance, and it will help you to improve your visual outputs. You can do multiple unit to test by just adding another command. Like when you are doing this, you can just add another command and create the output points here, and then create the unit to graphs. And if you want, then you can also add another command for, just like if I want to add for first difference. So I will just copy it and add it, and then d and then create output handles for that. I would have to add more handles and make sure that the names are not overlapping, so that I can also get the output for first difference. So this way you can create the codes, and do let me know how it performs in your own data, and how beautiful they look in your presentation of your results. Thank you very much.